Resolve 3x plus 2. Resolve 3x plus 2 over x plus 2 times x minus 5 into partial fractions. The first thing to do is to check if the fraction is a proper fraction or an improper fraction. Now, if we expand this denominator, what we're going to get is that will become x squared minus 5x plus 2x minus 10, which is x squared minus 3x minus 10. Now, we'll see that the degree of this product, the degree of the product is 2. So that means the degree of the numerator is 2. The degree of the denominator is 2. And the degree of the numerator is 1, which simply means the fraction is a proper fraction. For the fraction to be a proper fraction, the degree of the denominator must be greater than the degree of the numerator. If the degree of the denominator is less than the degree of the numerator, or it is equal to the degree of the numerator, then that fraction is an improper fraction. Now that we have seen that it's a proper fraction, we can now resolve into partial fractions. The first fraction will have a denominator of x plus 2, and the second fraction will have a denominator of x minus 5. Now, since the factors are linear, the numerators of their partial fractions will be constant, because a linear expression is a polynomial of degree 1. This is also a polynomial of degree 1. And the numerator of its partial fraction, the numerator of the partial fractions of each of them will be, the numerator of the partial fraction of each of the factors is going to be of a degree that is 1 less than this degree. So if this factor has a degree of 1, that means the numerator of its partial fraction must have a degree of 0. And a polynomial of degree 0 is the same as a constant. So let's call that A. This is also a polynomial of degree 1. So the numerator of its partial fraction will be a polynomial of degree 0, which is a constant. We can also call that B. If this factor, for example, is a polynomial of degree 2, that means it's going to be something like this: ax squared, or let me just use this. If it's a polynomial of degree 2, let's say x squared plus 3x plus 5. That's a polynomial of degree 2. That means the numerator of its partial fraction is going to be a polynomial of degree 1. So that's going to be a linear expression. So we write the general form of linear expression. You can see that this is a polynomial of degree 1 and this is a polynomial of degree 2. So when you are resolving into partial fractions, the numerator of the partial fraction of each factor at the denominator will have a degree that is 1 less than the degree of that denominator. This is a polynomial of degree 1, so the numerator of its partial fraction will be a polynomial of degree 0, which is a constant. If it's a polynomial of degree 2, the numerator of its partial fraction will be a polynomial of degree 1. If it's a polynomial of degree 3, the numerator of its partial fraction will be a polynomial of degree 2. So that's it. Now, let's find the values of A and B. The LCM is x plus 2 times x minus 5. And that simply means A into bracket x minus 5 plus B into bracket x plus 2. What this simply means is that 3x plus 2 over x plus 2 times x minus 5 is equal to what is on the right hand side. This is x minus 5. If the denominators are equal, that means the numerators are also equivalent, and this therefore means that 3x plus 2 is equal to A into bracket x minus 5 plus B into bracket x plus 2. So I can call this equation 1. Now, if I putting x equals minus 2, putting x equals minus 2 in equation 1. If I put x equals minus 2 in equation 1, that means wherever I see x, I'll write minus 2. That means 3 into bracket minus 2 plus 2 equals a into bracket minus 2 minus 5 plus b into bracket minus 2 plus 2. And that simply means this is 0. That will cancel out, and I'll be left with minus 6 plus 2 equals a into bracket minus 2 minus 5. And that simply means minus 4 equals minus 7a, which simply means a equals 4 over 7 if you divide through by minus 7. Now putting x equals 5 in equation 1. Putting x equals 5 in 1. 3 into bracket 5 plus 2. Don't forget this is equation 1. This is equation 1. So 3 into bracket 5, 3 times 5 plus 2 is equal to a into bracket 5 minus 5 plus b into bracket 5 plus 2 plus b into bracket 5 plus 2. And that simply means 15 plus 2 is equal to, this will be 0, is equal to b into bracket 5 plus 2. B into bracket 5 plus 2, which simply means 17 equals 7b. And that therefore means b is equal to 17 over 7. And therefore 3x plus 2 over x plus 2 times x minus 5 is equal to a over x plus 2, which is the same as 4 over 7 divided by x plus 2 plus b, which is 17 over 7 divided by x minus 5. And that simply means, of course, 4 over 7 divided by x plus 2 is the same as saying 4 over 7 times, of course, divided by x plus 2 over 1 is the same as times 1 over x plus 2, which simply means 4 over 7 into bracket x plus 2. So that's what I'm going to write instead of writing 4 over 7 divided by x plus 2. So that simply means 4 over 7 into bracket x plus 2 plus, this is also the same as 17 over 7 into bracket x minus 5. And that's the answer very, very simply. This method of substituting a value for x to cancel all the unknowns and leave only one. To cancel all the unknowns and leave only one is called the cover-up method. We put x equals minus 2 to cancel, to eliminate b and get a. So that method is called the cover-up method. And we put x equals 5 to eliminate a to get b. So the other method is the method of comparing coefficients. The method of comparing coefficients. Let's take an example and use that method to do that. Resolve x minus 1. Resolve x minus 1 over x plus 2 times x minus 3 into partial fractions. Now here, when we expand this, we'll see that it's a polynomial of degree 2 and this is a polynomial of degree 1. That simply means the fraction is a proper fraction. So this factor is a linear factor. So the numerator of its partial fraction will be a constant. Let me call that a plus. This factor is also a linear factor, and that means the numerator of its partial fraction will also be a constant. Let's call that b. Now, this is the same as the LCM of the denominators is x plus 2 times x minus x plus 2 times x minus 3. And that means a into bracket x minus 3 plus b into bracket x plus 2. Now what this simply means is that x minus 1 over x plus 2 times x minus 3 is equal to what's on the right hand side. If the denominators are the same, that means the numerators are also equivalent. That simply means x minus 1 equals a into bracket x minus 3 plus b into bracket x plus 2. Now, instead of putting x equals 3 to eliminate a and x equals minus 2 to eliminate b, I'm using the method of comparing coefficients. So I can expand what's on the right hand side. That will be ax minus 3a plus bx plus 2b. And that's x minus 1 is equal to ax minus 3a plus bx plus 2b. Now, comparing the coefficients of x, comparing the coefficients of x, the coefficient of x on the right hand side is a plus b. Comparing the coefficients of x, a plus b, the coefficient of x on the left hand side is 1. This is the same as 1x. So that means a plus b equals 1. Let's call that equation 1. Comparing the constants, the constant on the left hand side is minus 3a plus, the constant on the right hand side is minus 3a plus 2b. Minus 3a plus 2b equals, the constant on the left hand side is minus 1. So minus 3a plus 2b equals minus 1. And that's equation 1. What did we do here? We compare the coefficients of x and the constants. So we'll solve the two equations simultaneously. So let's solve that simultaneously. A plus b equals 1 and minus 3a plus 2b equals minus 1. Now, let me multiply equation 1 by 2 and equation 2 by 1 to eliminate b. So that means 2a plus 2b equals 2, and this remains minus 3a plus 2b equals minus 1. Now we can eliminate b by subtraction. 2a minus minus 3a, that's the same as 2a plus 3a, which is 5a equals, which is 5a. 2b minus 2b is 0, and that's equal to 2 minus minus 1. That's the same as 2 plus 1, which is 3. And that therefore means a equals 3 over 5. Now if I putting a in equation 1, that means wherever I see a in equation 1, I'm going to write the value of, I'm going to write 3 over 5. So that means 3 over 5 plus b is equal to, equation 1 is a plus b equals 1. So that means 3 over 5 plus b equals 1, which means b equals 1 minus 3 over 5, and that's equal to 2 over 5. So b equals 2 over 5, which therefore means x minus 1 over x plus 1 times x minus 2, x minus 1 over x plus 1 times x minus 3, not x minus 2, x minus 3, this is x minus 3, will be equal to a over x plus 1, and we see that a is 3 over 5, that's 3 over 5, that's 3 over 5 all over x plus 1, and I can write it simply as 3 over 5 into bracket x plus 1 plus b, which is 2 over 5 over x minus 3, which can be written simply as 2 over 5 into bracket x minus 3. And that's it very, very simply. That is the method of comparing coefficients.